What is the difference between our roads and universe? Universe is a speed limit. It's a good one. But physicist Miguel Alcubierre found a way to break that limit too.
Bro, general relativity forbids faster than light travel.
Ironically, he used general relativity to find the way. General relativity teaches us that space is malleable and huge masses or energy can deform space. Mathematically, general relativity stands on this equation known as Einstein field equation. Now, I know this equation looks complex, but it's super easy to understand. The right side, this thing collects data about mass or energy distribution where these all are constants. Now, if you put some data about mass distribution in the right side of this equation and solve the equation in the left side, you will get how that mass deforms spacetime. General relativity also says nothing in space can travel faster than light, but there's a fun fact. This limit is only for movement of object inside spacetime but not to the movement of spacetime itself. Now let's dive into the idea of Miguel Alcubierre with a cool analogy. Let's represent our malleable space with this slinky. Now the idea is, what if we take a region of space and put our spaceship there and expand space behind us and contract in front of it? That's how we can move at any arbitrary speed.
How will you deform space like this?
That's so easy. We have to contract space in front of us and expand behind us, so we know the geometry of the space-time. Alcubierre put the geometry of space in the left side and did back calculation to know what the mass or energy distribution should be to deform space like this. But what he got wasn't much impressive. It turns out that we need energy equivalence of more mass than our entire visible universe. That's impossible. What makes it worse than that is we need negative amount of it. So the idea is mathematically possible but physically impossible. But in 2011, NASA scientist Dr. Harold White further reworked on it, and surprisingly, he reduced the negative energy requirement to equivalence of minus 700 kg. It's still a lot, but it made the idea from impossible to at least plausible. What the heck is negative energy? To be honest, it's unknown to our known physics, but in quantum world, some theory proves existence of, but we can't harness negative energy from there. But there is something that can be hopeful for us. To explain expansion of universe, scientists discovered something called dark energy. It's named dark because we don't know anything about it. But our observation shows that it somehow behaves like negative energy.
New ideas are being proposed constantly. We, the youth of the world, need to study and research on it. Who knows, maybe one day you will propose your own warp type technology.